The curve U represents those combinations of x and y from which the individual derives the same utility. So the entire curve U, as you can see, it is showing the different combinations of x and y from which the individual is deriving the equal utility, same utility. The slope of this curve, it represents the rate at which individual is willing to trade x for y while remaining equally well off. It can trade some unit of x to get some more unit of y. Okay, so this is what the slope is showing. Okay, as you can see, the slope of this curve is negative. Okay, so the slope of the curve is negative, showing that if individual is forced to give up some of y, he must be compensated by additional amount of x to get or to remain at the same indifference curve. So if individual is foregoing this much amount of y, he should be getting this much amount of x more in order to be at the same indifference curve. Earlier he was at this point. Okay, he has given up this much amount of y. Okay, in order to remain at the same indifference curve, he has to get this much amount of x, so more amount of x. So the curve is drawn so that the slope increases as x increases. Okay, now this graphical representation of the assumption that individuals becoming less progressive, okay, becoming progressively less willing to trade away y to get the more of x. So what you're saying is that here, when you are at say y1, you have enough y. Okay, you can give up more and more of y in order to get one more unit of x because you had less amount of x here. Okay, as you can see, let me use another color. So at this y, you had more amount of y and less amount of x. Okay, now if you move to this point, say y2, you have more amount of x and less amount of y. Okay, so this is more x and less y. So as you move down, as you have more and more of x, you will be less willing to trade y for x. Okay, because you have more of x and less of y. Okay, so you're getting the point what I'm saying, this that you start up with a point, say like this. Okay, now at this point you have more y. Okay, you have more y and less x. Okay, while once you start trading y for x, okay, you come to a point where you have more x and less y. So you would want to trade less and less of it. You'll be less and less willing to trade y for x as you have more and more of x. Okay, so in mathematical terms, what does this mean? What does this mean is that slope diminishes as x increases. So when x is increasing, the slope is diminishing. So what is your MRS? MRS is the negative of the slope of an indifference curve at some point, and this is called your MRS. So this is the slope of an indifference curve at these points. Okay, and how do you find out MRS? MRS is nothing but minus dy by dx, okay, at u equals to say u bar at a given u. So this is the slope of an indifference curve. um, See, at point x1, y1, as you can see, the person has quite a lot of y and is willing to trade away significant amounts to get 1 unit of x. And this is what I've told you earlier also. So once he has traded y for x and he has come to the next point where y2 next to is there. So now he has more of x and less of y. Okay, so you would want to trade less. He'll be less willing to trade 1 more unit of y in order to get 1 more unit of x. Okay, so and this is your marginal rate of substitution. The changing slope of u, it shows how the particular consumption bundle available influences the trades this person will freely make. So all of these changing slopes, so I mean for this particular curve, the slope is not same. It is not same throughout the indifference curve. It is different at different points. So this changing slope, it shows how the particular consumption bundle available influences the trade this person will freely make. So this is what your marginal rate of substitution is. So and we'll be doing the different kinds of utility function for the function like this. This is reflecting a Cobb-Douglas kind of utility function. So your utility MRS is different at different points. There might be some cases in which MRS is constant. Say, for example, in perfect substitutes. Okay, and we'll be talking about them in different topic. So this is the logic of the marginal rate of substitution. Okay, the rate at which you are willing to trade one more unit of y, one more unit of x, or one more unit of y. Okay, so this is your dy by dx. Minus of dy by dx, that is a minus of the slope of an indifference curve, gives you marginal rate of substitution.